All right, guys. So these are the three questions that I sent you via email. So I'm going to go over them, and I'm going to show you how to do a couple of them using p-value and critical value. I hope that you try to do those problems, and then you can check your answers. A manufacturer claims that the mean lifetime of its lithium batteries is 900 hours. So I'm going to pause here and write the null in the alternative hypothesis. So HO, HA, mean is, it says is, so equal to 900. This is where the claim is. And you guys know now that the alternative hypothesis should be not equal to, the opposite. Assume that the population, okay, a homeowner selects 35, so N is 35 of these batteries, and find that its mean lifetime is to be 880, so X bar is 880. Assume that the population standard deviation is 80 hours, so sigma is 80 hours. Test the manufacturer's claim, use alpha equals 0.05. This is very important because we use it to compare it with the p-value. Okay, let's do it with the calculator. Since sigma is given, guys, what you use is what we call the z-test. So we're going to use the z-test. And let me just go and use the z-test right there. So that is how we use the z-test. You go to stat, then tests, z-test. By the way, I'm recording this session, so I will share the recording with you later today. So mu zero is the value from the null hypothesis, which is 900. Sigma, which is 80. X bar, which is 880. N is 35. And now, guys, the last step before you hit calculate, what sign do you have in the alternative hypothesis, which is not equal to? So this is this one. Make sure to select it and press enter and hit calculate. I got Z equals negative 1.48. And the p-value, that's the one that we're looking for. With 4 decimal places, you would agree with me, it's 0.1391. All right, and now we're done. We just have to make the decision. Since this p-value, now bring alpha to the play, guys. Put 0.1391 here and put 0.05 right there. And put a sign in between. Is it greater than or less than? Well, you agree with me that it's greater than. So then the p-value is more than alpha. If it is more than alpha, you fail to reject HO. And if it is less than alpha, you reject HO. So fail to reject HO. Now write the conclusion about the claim. Your claim is in the null hypothesis, and you could not reject the null hypothesis. Remember what I said last time. If you fail to reject HO, you start with there is not enough evidence at the 0.05 level of significance. Okay. 2, let's decide to support or to reject. Since the claim is in HO, we're saying that we cannot reject the claim. So you have to use the word reject. Remember, when you're claiming HO, you will have to use the word reject. And if a claim is in HA, you use the word support or not support. So there is not enough evidence to reject the claim that the mean, I'm just copying and pasting from the top, lifetime of the lithium batteries is 900 hours. And that concludes the problem, guys. Now I'm going to show you how to do the very same problem, but using critical values. So Let me show you how to do this. This is probably a part that many of you probably had a hard time when you try to do the homework, but remember, we did not get to that, just the last time we met. So, using critical values. Okay, for the p-value, guys, we compare p-value with alpha. Alpha is a probability, p-value is a probability, so we compare probability with a probability, apple with apple. With a critical value, we're gonna compare orange with orange, but let me show you how that works. But again, guys, if you wanna stick to the p-value, as far as the test concerned, that is fine with me. First of all, you still have to list the null and the alternative hypothesis. Nothing is going to change. You have to read and list the null and the alternative hypothesis. N is 35. I'm gonna write everything down. X bar is 880. Sigma is 80. And alpha is 0.05. Okay. Step number 2 is to find the test statistic. By the way, this is called the test statistic. You still have to do it. You guys can go to z-test and find it and get negative 1.48, or you can use the formula here, which is this. Okay, if I do the math, it's gonna be 880 minus mean. Which value do you pick? You pick the value in the null hypothesis, because we assume the null hypothesis is true until proven otherwise. So 900. Sigma is 80 over square root of 35. And when you guys do it on the calculator, put parentheses around the top, parentheses around the bottom, and you should get the exact same answer that I got, which is negative 1.48. Now I'm gonna show you how to find the critical values. So let's work on this one. That's the important part, and that's what's different. So instead of the p-value, we're gonna do the critical value. So watch. Let me just bring the microphone closer. All right, here's what you do, guys. Sketch this curve. And then you decide, is it a one tail, two tails, left tail test, right tail test, or a two tail test? Well, since this is not equal to, it's a two tail test. So you shade two tails here. Your critical values, guys, and this is a 0 right here. Okay. There is a number here and there is a number there, and they're exactly the same but opposite in signs, because this curve is symmetric. Those values are called the critical values. Your book columns Z0. One is going to be negative and one is going to be positive. But the question, how do you find them? Here is how we find them. This alpha here is the area. This is the rejection region, called the rejection region. Since it's a two-tailed test, we have two rejection regions. When you have two rejection regions, guys, it's just like the confidence intervals when you learned about confidence intervals. So take this alpha, which is 5%, and split it up on the two sides. If you split it up on the two sides, each one is going to be 2.5%, which is 0.025. And this area here, guys, is going to be also 0.025. Just like exactly a 95% confidence interval. You put 95% here and you split up the 5%. So this is how it works with two tails test. Now my question to you guys, I need to find this value here. This is called the critical value that separates the rejection region from the non-rejection region, from fail to reject region. If this area to the left is 0.05, do you still remember how to find, just this value? We use what we call the inverse norm. And we need the area to the left. What is the area to the left here? 0.025. And then comma 0, comma 1. If some of you have a calculator that says left, right, etc., you could just put here left because we're doing, the left one. And if you do the inverse norm on this one, let me do it, guys. It's going to be negative 1.96, and I'll show you. Okay. Let me just make sure that everything is good and the chat. Okay. Okay. I will answer that about how to decide about the null hypothesis, about how to reject or fail to reject. So let's do this first. So inverse norm, second distribute, guys, inverse norm, and I got 0.025. Now, maybe the question you want to ask me, do we always divide alpha by 2? No, only in the case when you have two tails. So 0.02501, and guess what? It's going to be negative 1.96, as I said. So let's put the negative 1.96 here. And this one is going to be 1.96. And now here's how you decide whether you reject or fail to reject HO. Watch. You have to put those the value of the critical value. Now bring the step number 2, which is negative 1.48. Put it on the number line here. Where would it end? Would it end below negative 1.96? It has to be below 0. But would it be to the left of negative 1.96 or to the right of negative 1.6? Since it's bigger, it has to be to the right. So it's right here. Okay, here's a question for you. Did it turn out to be in the rejection region or not in the rejection region? Can someone answer this one? Look at it. Is it in the shaded region or not shaded region? Not in the rejection region, I agree. So this is what you do, guys. Fail to reject HO. Now, let me tell you, let's say this was negative 2.7. If it was negative 1.27, will be right there. Then you reject HO. Let's say this was 2.8. If it was 2.8, it will be right here above 1.96, you reject HO. So if it falls on the line where you shaded, then you reject HO. If it doesn't fall on that line where you shaded, then you fail to reject HO. And you guys, the conclusion is exactly the same as we did before. There is not enough evidence at the 0.05 level of significance to reject the claim that the mean life of lithium batteries is 900 hours. So it's exactly the same as the statement we did with the p-value. So the only difference between the two methods, guys, is step number 3. Here you find the p-value. Over there you find the critical values. So let me just do another one, and then I'll do the critical value as well. So let's do the next one. A local juice manufacturer distributed juice in barrels labeled 12 ounces. A government thinks that the company is cheating. Cheating means they're putting less than 12 ounces. The agency select 36 of these bottles, so N is 36. Measure their content, obtain a sample mean of 11.7 ounces. Assume that the population standard deviation, I think it's clear to you guys, this is sigma, not S. Use alpha equals 0.01 significance level to test the agency claim that the company is cheating its customers using p-value. I'm going to do it with p-value and critical value, guys, and show you how that works. First of all, let's state HO and HA. Mean. You don't have to start with HO. You start with whatever it says. It says that less than 12 ounces. So mean is less than 12 ounces. And you guys agree with me that this is the claim. And I'm sure you know by now that the opposite of less than, it's a greater than or equal to 12 ounces. Okay. We're almost done with the p-value. Just plug in the numbers into the calculator. It's a z-test again. Stat, tests, Z-test, and watch, guys. Calculator works like magic. 12, sigma is 0.7, X bar is 11.7, N is 36, and less than, make sure to select it and press enter and hit calculate. Okay, step number 2, Z is negative 2.57. I'll write it down. And P is 0.0051 if you round to 4 decimal places. Be very careful, guys, when you do your homework online. By the way, I think the system is up and running now. They're still doing work, but I tried to log in and I was able to. So if you try later, probably it should be up and running. Okay, make a decision. Here's alpha, guys. Is 0.0051 less than 0.01 or bigger? Can a student tell me? Well, okay, less than, I agree. And if it is less than, what do we do? You need to memorize this, guys. You cannot mix this up. Reject HO because, and if you want me to put Y, because the p-value is less than alpha. Okay, write your conclusion now. Our claim is in HA. We reject HO. This is bad. And our claim is in HA. That means our claim is good because this one is bad. So we support HA. We say there is enough. And guys, this language is not up to you to decide how to word this one. This is how you should do it. Enough evidence at the 0.01 level of significance. What is the level of significance? It's the probability, maximum probability allowed to make a type 1 error. Type 1 error is the mistake of rejecting HO when it isn't actually true. So there is enough evidence at the 0.01 level of significance to support the claim that the brewery, oh, that's serious for them, is cheating. That means, yeah, probably they are cheating their customers. And that concludes the problem, guys. Now I'm going to show you how do you do this problem using critical values. So bear with me for a second and show you how to do the critical value approach. Watch. All right. Using critical values. Same again, guys, you have to state HO and HA, no change here. Less than 12. And this is where the claim is. You have to find Z. Again, you can run the Z test just to find Z if you don't want to do the work, but this is the formula. So the critical value is mainly when you do your work by hand. Well, although we're not doing the work 100% by hand, we are using technology. But if you do X bar, which is 11.7, minus the mean, which we assume it is 12, until proven otherwise, and 0.7 divided by square root of 36. Well, I'm not going to do the math, but you know it's going to be negative 2.57. Now, critical value. Look what you do, guys. Okay, this is 0 here. Okay, what's alpha here? 0.01. And what do I have? A right or left? I have a left tail test, so where do I shade? To the left. And this is your 0.01, guys. So I want you to help me find the critical value here, which is inverse norm. And what is it gonna be? It's gonna be area to the left, 0.01, comma 0, comma 1. Let's do it on the calculator, guys, and show you how to do it. Could use table 4, but I think it's easier for you to use a calculator. So distribute, inverse norm. Oops, let me quit. Inverse norm, 0.01. I think it's going to be negative 2.33. Negative 2.33. Because I use it a lot, so this value. So negative 2.33. Now watch. Negative 2.57, where would it land? You guys agree with me, negative 2.57 is smaller than negative 2.33, so it should be here. You don't put it anywhere you like. You just put it either before or after, wherever it belongs to. And can a student tell me, what do we do now? Do we fail to reject HO or reject HO now? Remember, it turns out in the shaded region, and shaded region is the rejection region. Yes, we reject HO. And then guys, step number 5 is exactly the same as you put. Remember, if you reject HO with p-value, you must reject HO with the critical value. And we did reject HO with the p-value. So you have to be consistent. It's two different ways. One way you compare apple with apple, and the other one you compare orange with orange. P-values are probabilities, and alpha is a probability. Critical values, guys, are numbers. Z is statistic is a number, and the critical value is a number, so you compare numbers. Remember, you cannot compare apple with an orange, so you either compare p-value with alpha or you compare a number with a number critical values. Any questions, guys, here? So this is how we use the critical value approach. I'm going to go to the next question. There's one more actually I gave you. A bank claims that the mean waiting time in line is less than 3.3 minutes. A random sample of 25 customers has a mean of 3.1 minutes. Assumed population standard deviation of the wait time is 0.8 minutes. If alpha equals 0.05, test the banks using p-value. So we'll use p-value now. So they claim that the mean wait time is less than 3.3 minutes. Would you guys agree with me if I do HA first? Less than 3.3 minutes. You can put the unit here if you want. You don't want to do that, that's fine. And HO is the total opposite. And we discussed last time, the opposite of less than should be greater than or equal to. You must have equality in HO. Okay, N is 25. X bar is 3.1. Population standard deviation is 0.8. And alpha is 0.05. Okay. I think you're used already pretty much to the Z test, guys. So I'm going to go to stat test. Next one is going to be the T test. Mu is 3.3. Again, the value from the null hypothesis. Sigma is 0.8. It's very straightforward, guys, once you get used to it. 3.1. N is 25. Even when you do your homework online, if he asks you to calculate the test statistic Z, you can use a calculator to find it and just plug it in. So less than, and then hit calculate. And I got Z is negative 1.25, guys. You can see it right here. And the p-value, 4 digits, I got 0.1056. And you guys, would you agree with me that this is bigger than alpha, which is 0.05? And if it is bigger than alpha, the decision is going to be to fail to reject HO. So what's the conclusion? We fail to reject HO, but our claim is in HA, so we cannot support the claim because we fail to reject HO. If we were able to reject HO, then we support the claim. So remember what I said last time. Anytime you have a failed to, you have to start with there is not. enough evidence at the 0.05 level of significance. 2. If you get confused here, guys, do I say reject or support? This is the clue. If your claim is in HA, you must use the word support here to support the claim that mean waiting time at the bank is less than, just copy it. Waiting time in line is less than 3.3 minutes. All right, guys, so that concludes the review sheet. So the population parameters of interest for us in this chapter: mean, proportion, it's coming today, and then sigma. Okay. A hypothesis is a claim. If you want, I can send you a clean copy of this so you guys can fill it in if you like. For example, a politician claims that a majority of citizens support Social Security reform. She takes a random sample to see if the data support the hypothesis that majority, do you guys remember what majority means? P is more than 0.5. So if you have majority, that means you're over 50%. Or we may not trust the claim that Frito-Lay when it says that the bag of Ruffles weigh 14 ounces on average. So we suspect that they're wrong. They're not putting 14. So if you want to check your suspicion, you want to check if they're putting less than 14, because when you're suspicious, that means they're cheating. So it's less than 14. Remember, when we do a hypothesis test, it's not about, just the sample mean. It's about the population parameter. So you only test those values, not X bar, not P hat, only mean and P, mu and P. That's what we test here. So a hypothesis test is a method using data from a sample to decide between two competing hypotheses. The two competing hypotheses, guys, are HO and HA. Okay, in a hypothesis test, we initially assume that the one hypothesis is true. This is called the null hypothesis. Just like when we say the defendant to begin with is not guilty until proven otherwise. We then consider the evidence from a sample and reject the null hypothesis in favor of what? If you reject the null hypothesis, then you will be favoring what? The alternative hypothesis. Okay, in general, a quick review, guys. If HO has an equal sign here, then the HA will have what? Not equal to. These two together, don't forget. If HO has a greater than or equal sign, this one will have a less than. These two are together always. And if HO has a less than or equal to, this one has a greater than. The hypothesized value is the same for both, because when we put mean greater than or equal to 15 and then less than 15, we use the same value, so it's the same. Oh, you already have a copy of this. I emailed that to you guys. Some more examples on how to state the null and the alternative hypothesis. A school administrator claimed that the mean SAT score is more than 1300. Would you guys agree with me that more than 1300 here? And this one will be less than or equal to 1300, and that's the claim. A car battery manufacturer claimed that the mean lifetime of a certain battery is at least 5 years. What is at least, guys? This you need to know. This is the algebra that we need, greater than or equal to. So that will be in the null. What did he say? 5 years. And that's the claim. In real life, guys, most of the claims end up in HA, but in your book, he has many probably claims that turn out to be in HO. A statistician a statistician or a statistics class teacher claimed that the proportion of students who earn an A is less than 40%. So would you guys agree that less than 40% is right here? And P is greater than or equal to 40%. You can put 0.4 if you want. Okay. We reject HO when the data from the sample suggests it's not true. That means when we have enough evidence beyond reasonable doubt that HO is false. If the sample does not contain such evidence, we fail to reject HO. We don't say accept, guys. Remember, we say the defendant is not guilty. We don't say it's innocent, because we cannot accept, just that. So that is, we fail to reject HO when the result could be due to sampling variability. You need to be careful when you interpret the results of a test of hypothesis. If you fail to reject HO, it doesn't mean that you what? I just said the word, prove that you accept. It just means that you don't have strong evidence against it. That's why defendants are declared not guilty and are not declared, you guessed the word, guys, innocent. Okay. There wasn't enough evidence to convict them, but that doesn't mean they are innocent. Thus, we never accept a null hypothesis. We only fail to reject it. So what I'm trying to tell you guys, if you fail to reject HO, don't change your wording and make it accept. Just keep it, fail to reject HO. The significance level alpha, guys, I told you it's a maximum allowable probability of making type 1 error. Type 1 error is when you reject HO when it is actually true. You reject something that's true. That means you made a mistake. Type 2 error, when you fail to reject HO when it is false. Also, this is an error. You are failing to reject something that's not true. We discussed the p-value already, so I put a definition again for the p-value. And I want to go just through this quickly with you. The truth of HO. If HO is true, guys, and you reject it, that means you made a mistake. And this mistake is called type 1 error. If HO is true and you don't reject it, that's a correct decision, because you're not supposed to reject something that is true. If HO is false and you reject it, that's good too, because you're rejecting something that is false. So that is a correct decision. Now, if HO is false and you fail to reject it, well, you're supposed to reject something that is false. So that's a type 2. And we discuss 3 types of test. Left tail test, which is when HA has this sign. Right tail test when HA has that one. And 2-tail test, guys, when HA has this sign. Okay. Steps of hypothesis testing. There are 5 steps that I've been talking about. The first one, to state the null and the alternative hypothesis. Calculate the test statistic. Find the p-value or the critical value, make a decision to reject HO or fail to reject HO, and then write your conclusion in the context of the claim. Now, what we're gonna do, this exercise. Still on the Z test. We're gonna get into the T test, guys, shortly. The Center of Disease Control, CDC, reported on trends in weight, heights, and body mass index from 1960 through 2002. The general trend was that Americans were much heavier and slightly taller in 2002 as compared to 1960. Both men and women gained approximately 24 pounds on average between 1960 and 2002. In 2002, the mean weight for men was reported to be 191 pounds. Suppose that an investigator hypothesizes that the weights are even higher than what? 191. That the trend continue over for the next 4 years. So we're gonna list now HO and HA. So the investigator is saying that it is higher than 191. So if I write, guys, the null and the alternative hypothesis, mean is greater than 191 pounds, that's the claim. And the null hypothesis will be less than or equal to 191. In order to test the hypothesis, we select a random sample of American male in 2006 and measure their weight. Suppose we have resources available to recruit N100 men. X bar is 197.1, guys, and sigma given to you to be 25.6. Do the sample data support the investigator's claim? Use 5% level of significance. I just did a lot of wording explanation, guys, but I'm just going to get to it right away here. So I'm going to go to the calculator and show you how to proceed from there. Clear. Stat, tests, z-test, okay, mu0, 191. This is the value that we're saying that it's beyond 191. Sigma, 25.6. X bar, 197.1. And what else? N is 100. And then greater than. Here you go. Calculate. Z is 2.38. So here's my Z. If you're using your calculator, you don't need to show the work like I did here, but I've just shown you the formula. Now, what's the p-value? The p-value is 0.0086. I'll write it down. Okay. If do you guys agree with me that the p-value is less than alpha? Alpha, he says 0.05. Okay, so what's the decision if the p-value is less than alpha? Can a student tell me? So my p-value 0.086 is less than alpha. What decision do I make? Reject HO or fail to reject HO, guys? Yep, reject. And when we're rejecting HO, and the claim, guys, look, the claim is in HA, so we support the claim. We say there is. So we have enough evidence against HO, guys. That's what I try to explain here. There is enough evidence at the 0.05 level of significance. Get used to this language, guys, to support the claim that the mean weight is more than 191. And that concludes the problem. There you go. All right. One more, guys, about sigma known, and that would be it. I'm not going to do any more problem when sigma is known. We're going to get to the fact that sigma is not known. This is the more important fact. The EPA reports that exhaust emission for a certain car model has a normal distribution with the mean of 1.45 grams of nitrous oxide per mile and a population standard deviation of 0.4. So sigma is 0.4, guys. The car manufacturer claims that the renew process reduces the mean level of exhaust emitted for this car model. Okay. The EPA reports that the average emission is 1.45, but a car manufacturer claimed that their process can reduce this mean level of exhaust emitted. Would you guys agree with me if I state reduce means less than 1.45? So they claim that they can do better with emission, and this one will be greater than 1.45. A simple random sample of 31 cars, 31, is taken and the mean level of exhaust emitted for this sample is 1.21. All right. So maybe a student here What about now? Is it still frozen? I got a student told me the camera is frozen. Is it still? I see it okay from my side. Can you guys let me know if it is good now? Okay. Okay. Yeah, as long as you hear me, guys, that's what's important to me, and then you can see the text later. So Z is, okay, we're gonna do it on the calculator. Watch. Clear. Set. No more Z test after this, guys. Data, stats. Okay, mu 0, 1.45. Sigma, 0.4. I'll try not to move a lot so then the screen doesn't get frozen. X bar is 1.21. N is 31. And which sign do you use? Less than. And then calculate. And I got Z is negative 3.34. I'll write it down and watch, guys. And see here, E minus 4, what does it mean? It means you have to move your decimal place 4 digits to the left. Don't forget that. Always look if there is an E at the very end. So it will be negative 3.34. And the p-value is 0.0004, which is very small, guys. You can say it's less than alpha without even knowing what alpha is. And alpha, he says, oh, did I give you alpha here? Okay, I didn't give alpha, so use 0.05. I did not put alpha, the value of alpha, but the statisticians say if alpha is not given, use 0.05, but I will always provide it. I just, oh, I did right here in D, sorry. What is the decision at the 0.01 level of significance? Still, it's less, so we reject HO. P-value is less than alpha, we reject HO. What do you conclude? Okay, if you reject HO, guys, and the claim is in HA, you support the claim. There is enough evidence at the 0.01 level of significance to support the claim by the car. And just write it down, guys. Write the entire claim. You don't need to make it up yourself. Just it's already there. Look. The car claims that the new process reduced the mean level of exhaust emitted for this car model. Just write it down. All right. So that concludes, guys, section 7.2, using z-test when sigma is known. Now I'm going to show you things are not going to change much. You're going to be doing the same thing when sigma is not known, and this is really the important case, the very common case. We're doing section 7.3 right now. Watch, guys. Number 2. The amount of water consumed per week by Montana residents is normally distributed with an unknown mean. A simple random sample of 26 residents, so you guys agree, N is 26, has a mean value of 120.3 gallons. And a standard deviation of 10. I didn't say population standard deviation. I'm just talking about the sample. So you guys agree with me that should be S. Unless if it says a population standard deviation, it is S now. Gallons. The city of Bozeman claims that the average water consumed in the state of Montana is not 125 gallons. So let's write the null and the alternative hypothesis. Okay. Mean, they say it's not 125. So that will be it right here. That's the claim. And here equal 125. Okay. You guys, when sigma is not given and S is given, we use a T distribution, just like when we talk about confidence interval. And instead of a Z test, it's going to be a T test. And I'm going to show you how that works. You see here what I put here, calculate the test statistic. I didn't put Z, I put T. And actually the formula is very much the same, guys. It's X bar minus the mean divided by, remember when we did the Z-test, it's sigma, but instead of sigma now, I'm going to put S over square root of N. And if I do the math, I'm just going to show you, I'm going to plug in the numbers, but I will use the calculator. 120.3 minus 125 divided by 10 over square root of, what was the sample size? 26. Okay, look what you do, guys. Very simple. Using the p-value, it couldn't be any easier here. Stat, tests. Remember, you cannot use the z-test. It's a t-test now. We're using a t-distribution. The difference between the t-distribution and z-distribution, the t-distribution has a thicker tail, as you noticed, and it has degrees of freedom. As the degrees of freedom increase, the z and the t will become very close together. So mu 0, 125, X bar, 120.3, enter. S is 10, N is 26, watch guys. And now we need to choose which sign the first one, and then calculate. And that's what I need T and I need the p-value. So let's take a note of T. 3 decimal places for T, guys. So it's negative 2.397. If you do the math, you're going to get this number. And the p-value, let me write it down. Let me show you again, 0.0244. Okay, let's go to the next page. What decision do I make, guys? 0.0244, let me write it down here. Okay, he wants us to do it at the 0.01 level of significance. Do you guys agree with me? This is bigger than alpha. So if it is bigger than alpha, we fail to reject HO. Okay, if we fail to reject HO and my claim is in HA, well, how do you start? Again, there is not enough evidence at the 0.01 level of significance. Okay, I'm gonna pause and I want the students to tell me what the word here is. It gonna be support or reject? Let's see. To support, yes. Remember, when the claim is in HA, we use the word either support or not support. Here, we cannot support. To support the claim by the city of Bozeman. And you write it down, that the average water consumed in the city of Montana is not 125. All right, let's do another one with it. So how do we know if it is a t-test? When S is given instead of sigma, it is a t-test. Let's go to the next one. This one, guys, I'm gonna do critical value and p-value, both together, just to give you an idea. A credit card company wondered whether giving frequent flyer miles for every purchase would increase card usage, which has a current mean of 2,500 per year. So the trick here, guys, is to learn how to write the null and the alternative hypothesis. They're saying they want to increase the card usage, and they say the current use is 2,500. So would you guys agree with me if I tell you here, if they want to increase the current usage, that means they want the mean to be what? Bigger than 2,500. They want people to spend more money on the credit card, and there will be less than 2,500 here. So that's all. Sometimes they don't give you the wording exactly and directly. You have to think about it, but that's what it is right here. They gave free miles to a simple random sample of 24 credit users. And they found their sample mean to be 2542. So X bar, guys, is 2542. With a sample standard deviation S. You see, I put sample here, so don't use sigma, it's S. Okay, let's do it with the p-value first. Using TI-84 and t-test. Okay. You see, guys, once you set up the null and the alternative, it's done. And if you know which test you are using, I doubt it if you'll make a mistake here. So I'm gonna go stat, tests, t-test, and watch. To 2500. X bar is 2542. What do you think, guys? Is 2542 a lot more than 2500? Do you think that people are increasing their usage? The question is the $42 difference, is it statistically significant or not? So we'll find out with the hypothesis test. 109, and guys is 24. And which sign do I use? Greater than. It's always the alternative. And watch, calculate. So I got T is 1.888. And the p-value, guys, is 0.0359. Okay, what we're testing against, alpha is what? 0.01, guys. Do you guys agree with me that this is bigger than alpha? So that will be what? Fail to reject HO. And what's the conclusion? There is not enough evidence at the 0.01 level of significance to support the claim that given frequent miles will increase usage. Although the sample mean was more than 2,500, guys, but it's only $42. So that's not what the banks look for. They want people to spend a lot more. So that's why we ended up not supporting the claim that the frequent flyer program works. So maybe this is to tell the bank they should discontinue this program because it's not working for them. Now, let me show you how to use the critical value. So, critical values. You might find it easier than the critical values for the z-test. You will see it's very, very easy. So HO, you have to state them. You have no choice. You still have to learn how to do those. All right, so this is now T test the statistic. Again, you can run the t-test to find it, guys, but you can also do the math here, which is gonna be X bar is 2542 minus the mean 2500. You take it always from the null. Assume the null is true until proven otherwise. 109 divided by square root of 24. And guys, I'm not gonna do the math. I know the answer is 1.888. Now, how do you do the critical value? You do this. You do the 0. Okay. Now, is this a right, left, or two-tailed test? Well, you guys can see it's a greater than, so it's a right-tailed test. So you shade toward the right. What's alpha here? Alpha is, and the problem was 0.01. And I need this critical value, guys, but it's not called Z0 like in Z-test. They call it T0 in your book because it's a T. Okay, how do I find T0? Not inverse norm. There are two ways to find it. Using technology, you use inverse T. And you only need two arguments, guys, to find it. The area to the left, and the degrees of freedom. Okay, if n is 24, guys, what is the degrees of freedom here is 23. Now, if this is 1%, what would be the area to the left of T0? If the area to the right is 1%, it will be 0.99. But let me tell you something, guys. Even if you put 0.01 here, it's okay. You can do it. You're going to get a negative answer, but you know you can't have a negative answer because you're on the right of 0, so you just switch it to positive. So 0.99, and let's do it. And I'm going to show you how to do it using the table as well. So let's find this inverse T. Let me just put the calculator here, right here. So be careful, guys. You can't use inverse norm here. Then you'll be using the Z-test. Area is 0.99. Degrees of freedom is 23. And then paste. 2.499. So it's 2.5. Okay, guys. 2.5. What's my test statistic? 1.88. Would you guys agree with me that 1.88 should be here? And now I want a student to tell me what the decision is going to be. Well, it's not going to change. So what do you guys think? Fail to reject HO because we're not in the rejection region. Would you guys agree with that? Fail to reject HO. Again, if you ask me again why, because my 1.88 ended up on a number line that doesn't have a shaded region. If T was 2.8, guys, it will be here, then I would reject HO. And then the conclusion will be exactly the same. So another way, guys, to find. Oh, somebody asked me, how did I get the 99? Good question. Okay. This area, the alpha, this is alpha, which is 0.01. If you deduct, we need the area to the left. So if this is a 1%, this area is 99%. How did I know that? It's 100% minus 1%, so I got 99%. But as I told you guys, if you put 0.01 there, watch. It's okay, no big deal. I'm gonna do 0.01, show you what happens. Let's say students did not notice, so I put 0.01. And then degrees of freedom is 23, paste. You see what I got? I got a negative 2.5. If you round this to 3 digits, but you know your area is on the right. You can't have a negative 2.5. It has to be positive. So it's just get rid of the negative sign and put 2.5, and that should work. Let me show you another way to do this. You can use your table 5. You will use your table 5, which you already should have a copy of this. And you will go to alpha equals 0.01 and degrees of freedom equals 23. And I'm just going to show you the table. Just 1 second. Okay, watch, guys. We have a one-tail test here. One tail, not two tails, so you have to choose. This we use in the confidence interval chapter. Now it's one tail or two tails. You guys agree with me it's one tail, and you agree with me alpha is 0.01. So look, you look for 0.01, it's right here. You look for the degrees of freedom, which is 23, and watch. It's 2.5. Now, if you have a left tail test, guys, You will still do the same thing. You're going to get 2.5, but remember, a left tail test, the critical value should be negative. So you change this to a negative 2.5. So that doesn't give you a positive and negative. It only gives you a positive. You just change the sign and you should be okay. Now, if you have a two-tailed test and he gives you alpha, you follow this line right here. 2.5, let's say alpha is 0.01, you just go here and then degrees of freedom and you get the number. You don't have to worry about splitting up alpha or anything. You just use the table as is. I'm going to prepare actually a couple-minute video just for using, you know, just this table right here. So this is how you use the table. But again, guys, if you're comfortable with the p-value, you can use the p-value. So I'm going to stop sharing and then go to share the screen again. There you go. All right. Next question. Let's do this one together. A fast food outlet, maybe you think we did this one, but I did it with the sigma. Now I'm going to do it with the S. A fast food outlet claims that the mean waiting time in line is less than 3.5 minutes. We did a 3.3 minutes. So let's write the claims. And this is greater than 3.5 minutes. And here's the claim, guys. It's in HA. Remember, if you're claiming HA, then you have to use the language of support or not support. A random sample of 15, so N is 15, has a mean of 3.6. Standard deviation, it didn't say population, so you use S, 0.6. If alpha is 0.05, test the fast food outlets claim using p-values here. Sorry, not confidence intervals. Assume that the population is normally distributed. Why did he say make this assumption? Because our sample size is less than 30. Okay, you guys, if you know what to do, it's a t-test. I can tell you the big problem that I run to on with this one is students confuse the z-test and with the t-test. If you guys can learn how to clarify which is which, you shouldn't have any problems. So stat, tests, and then it's a t-test. Why a t-test, guys? Because S is given, not sigma. T-test. Okay. Mu0 is 3.5. X bar is 3.6. Okay. S is 0.6. N is 15. And we're doing less than. Okay. And then calculate. I got T to be 0.645. Check them later at home, guys. Just do those exercises again and make sure that they match. And I'm gonna scan this and send it to you. 0.7355. Oh, it's a huge p-value. Well, if p-value is big, guys, you fail to reject HO. Remember, if p-value low, HO must go, but not in this case. So p-value is more than alpha, we fail to reject HO. And if we fail to reject HO, guys, what's your decision? There is not enough evidence at the 0. Whatever the level of significance was, 0.05 level of significance to support the claim. We cannot support the claim, period. Especially with a larger p-value. The claim by the food outlet. Okay, so this is how we do this one. For the next exercise, guys, I'm gonna pause for a minute and I'm gonna have you enter the data into your calculator because now you have a raw data set. We've been using a summary, This time, they might give you the data. So I would like you not just to input those in L1, please. All right. So let's go back to this exercise. Carolina Tobacco Company advertised that its best-selling non-filtered cigarettes contain at most 40 milligrams of nicotine. Okay, can you guys help me state the null and the alternative hypothesis? What's at most? At most means less than or equal to. That's the claim. So it turned out to be here in the null hypothesis. And what's the opposite? Greater than 40 milligram. Okay. It's a serious matter. So a consumer advocate magazine ran tests for 10 cigarettes. It's a serious matter to charge that the company advertisement is wrong. So somebody is suspecting that they're wrong. So the magazine editor chooses a significance level of 0.01. Can the editor prove that the mean nicotine level is greater than 40 milligrams? So sorry, I rushed here. Let me just, it's not what the tobacco company who was making the claim, it's the editor who wants to check. So we're doing the editor questions. We're not answering the company. The company is not doing any, they advertise, but they didn't make a claim. Can the editor prove that the mean nicotine level is greater than 40 milligrams? So this is where our claim is. It's the claim is that what's the question, what the question is, and then he's asking us that to prove that it is greater than 40 milligram. I rushed and put this before I read the whole thing. Now we need to find the test statistic, guys. Okay, it's a t-test. And if you tell me why a t-test, he didn't give you population standard deviation. And look, guys, every time you have a raw data, it's usually a t-test. You can link this to this fact that it will be a t-test. So let's run the t-test and let me show you how different it's going to be. Not much different, so watch. You go to number 2, t-test. Okay, that's the difference. We don't have a summary anymore. We have data, so you have to move to data. Enter. Mu0, what's the value we're testing against? It's number 40. Now the list, where is your list? I put mine in L1, guys, so I'm gonna put it in L1, so second and number 1. And please do not change the next one frequency. It should always be at 1. Never change this one, guys. All right, so this is, and then the alternative hypothesis, what is it? Greater than, you can see it's a greater than. And now hit calculate, and that's it. So T is 2.746. And let me read the p-value together. It's 0.0113. Okay, we're done with the calculator, guys. Alpha is 0.01. Let me put alpha 0.01. Can a student tell me, is it greater than or less than? So what do we have here? Just one student answer. Is 0.0113 bigger than 0.01 or less than 0.01? I'm sure all of you know that. Okay, greater than. Muhammad says is greater than, I agree. Yeah, also 0, 0, 1, 1, but look, here I have a 1, here I have a 0. So yes, it is greater than, fail to reject HO. And your decision, fail to reject HO and the claim is in HA, you cannot support the claim. There is not enough evidence at the 0.01 level of significance to support the editor's claim that the mean nicotine level is greater than 40 milligrams. He could not prove that. But if the editor uses 0.05, guys, then you will end up rejecting HO. So alpha is very important. If you change the value of alpha, it will change, will tweak the entire problem and put us in a totally different direction. So this is how you work when you have a data set. All right. Any questions, guys, about this one? So again, when I give you a raw data set, guys, you can 99% sure that it is a t-test. You just run the t-test. Put your data in L1 and run the t-test and make sure to change the stats to data and then go from there. All right. Now section 7.4. Testing a claim about the proportion. This is section 7.4. We're not going to change much, guys. You're going to see we're going to keep going with what we did. That's why I spent so much time on section 7.1 and 7.2, because everything else, it just follow, just the same footsteps. So now we're not going to be testing the mean anymore. We're going to be testing the proportion. I'll just do a few problems here, guys, and then that would be it. For section 7.5, I'm going to postpone that for now. If we have time, we'll come back to it. But I want you to do 7.1 to 7.4 for now. So just focus on those sections, and you should be able, to work all of them this week after I'm done with this. The engineering school at a major university claims that 20% of its graduates are women. In a graduating class of 210 students, 46 were women. Does this suggest that the school is believable? So what's the claim made by the school, guys? We're talking percents now, so it's no longer the mean, it's a P. They say that the percent of graduates who are women is 20%. So it just put equals what? 1 second, let me just make sure that recording is working. Yeah. So P is 0.20. And what's the total opposite of equal? Not equal. And this is the claim made by the school. All right. Let's walk you through this and show you how to run the test. This is new, guys. We haven't done that yet because we're testing the proportion. So when you test the mean, you have two tests, either z-test or a t-test. We use z when sigma is known. We use t when sigma is not known. Here, it's one test for the proportion. It's called one proportion z-test. You're not gonna miss it, guys. But in order to run this test, guys, you have to verify two things. You have to verify that n times p is bigger than 5 and n times q is bigger than 5. P is the probability that's given to you here, and q is the probability of failure. So if this is 0.20, the q will be 1 minus p, which is 0.8. So this is a requirement in order to run the test. Let me check if we meet the requirement. Usually when I ask you to do the test, we'll definitely meet the requirement. So what's n here? N is 210. In a graduating class of 210 students, 46 were women. Do you guys remember what the 46 is? The number of successes. It's X. So you only need n and X to run this test. That's it. No mean, no standard deviation, no nothing. It's total size and number of successes. That's it. So NP. N, guys, is 210. And P was 0.2. If you multiply, guys, definitely you're going to get it more than 5. You check, put a check mark. Now, if I take 210 and multiply by 0.8, And again, if you ask me where did I get the 0.8, take 1 and subtract 0.2. Again, guys, it's bigger than 5, so you're good to go for the test. Find the test statistic. The test statistic, guys, is Z. Again, you don't need to do the work by hand, but I'm going to give you the formula. It's a p hat minus p divided by square root of pq over n. Okay. Now the question is p, we will use the one in the null hypothesis, 0.20. But what is a p hat? P hat is called the sample, the proportion from the sample. He gave you x and he gave you n. If you remember when we did confidence interval, the p hat is x over n. So it's 46 divided by 210. Okay, let me divide this and tell you what p hat is. But again, you will see you don't need to do any of this work if you're using calculator, but just to show you what the formula was. It's 0.22. Okay, so if you guys doing it by hand, you put 0.22 here minus 0.2 divided by square root. P is 0.2. Q is 0.8. And then you divide by N, which is what? 210. And I'm going to wait to get the Z because I'm going to use the calculator now to find this one. Okay, here's how you do the test, guys. Watch. This is in U. Stat, test, not Z test, not T test. It's number 5, proportion Z test. Okay. P0, it's asking you to put the value from the null hypothesis, just like in the previous test, which is 0.2. X is the number of successes, which is 46. Watch. N is 210. Now you have to choose the sign in the alternative hypothesis, and it's not equal to. There you go. I see.
Sir,
oh, you guys, can you hear me?
Can you hear me, Fuzzy?
Oh. Let me see. Oh, I'll go repeat it. Yeah, no problem. But let me just make sure that you guys can hear me first. What about now? Is it clear now for everybody? That's strange. I'm using a very expensive microphone here. Now? Can you hear me now, Ghadir? But the camera is frozen. Oh, it's still frozen, huh? Okay, okay, just one sec. You can see me, right?